Hey class, I wanted to make a short video to talk about this problem from the workshop that many of you are asking about. Here we have a skier who starts at the top of this initial plateau, just barely starts going down the hill. So if they just barely start, we can assume that V initial is going to be 0 meters per second. We're going to call this the initial point in time to analyze here. So initial. And then eventually comes to the top of the second hill here, which we'll call final. And we're told at that final situation, we have a scenario where the skier just barely begins to lose contact with the snow. Interesting. I hope that's helpful later on. And we're asked to determine what this height is here, labeled h. So as I see this, my first thought is to go with conservation of energy. We know up at the beginning, we're going to have gravitational potential energy, mgh initial, but since V initial is 0, there's no initial kinetic energy, and there's no springs or anything, so there's no potential energy due to elastic sources. And then, since we're told to neglect friction and air resistance, we will have 0 non-conservative work being done. So mgh initial is going to be the only energy that we start with, and then our final energy down at the end is only going to be kinetic energy, 1/2 mv squared. And so if we want to try to solve for this h value, it looks to me like h is just going to be equal to v final squared over 2g, which is great, except we don't know v. We do know g, and all we're given is this radius of this circular portion of the hill over here. So the question is, can we use that to somehow figure out v? Well, not sure. We are told this interesting fact about the skis losing contact with the snow at that point. So maybe I should draw a free body diagram. Normally for a skier going on a horizontal part of a slope like that, we would have a normal force going up, and we would have mg going down, and that would be the entirety of some of our forces. However, if we're told that the skis are just barely losing contact with the snow, that to me implies that the normal force at that instant must be equal to 0. And so for my free body diagram, I would actually erase this, and all I would have is mg pointing in the downward direction. Which seems weird. That must mean there is a net force, and that net force is going to be in the downward direction. And so if I added up my forces, in fact, and did sum of the forces in the y direction equals ma, I would just have a negative mg going down equals m times a negative a. Well, my m's would cancel, okay, sure, so the acceleration at that point must equal g. However, still doesn't really help me solve, although since I'm going through a circular trajectory at this point and moving tangent to the curve, that skier must be experiencing centripetal force to hold them in their circular pattern, and so that acceleration here must actually be a centripetal acceleration, which we know centripetal acceleration is v squared over r, and oh boy howdy, check it out. V is actually just the square root of g times r. If we pop that in up here, I bet we'll find a pretty simple and interesting solution for the height. I'll let you guys finish up the problem from here. Hope that helps, and have a box-worthy night.